Vectors. A vector quantity can be represented with a directed line segment. Any line segment that has a direction, it's called a vector. So for the vectors, two terminology is important. The length of the vector, which is called the magnitude, and the direction of the vector, which we can show the direction by finding the angle that the vector is making by the x-axis. For vectors, for finding the name of the vector, we have different form of showing the name of a vector. We can show the name of a vector by just giving a name like vector u, or just call the name of the vector by looking at the initial and the terminal point of the vector. And we always start from the initial. So for the first example, we call the vector OP, or we can call it vector U. And to show the magnitude or the length of the vector, we put that in as absolute value notation, but for the vectors, this is called the magnitude or length. Or in some books or example, you may see two lines instead of one line. That is also called the magnitude of the vector. In books, you may see that the names of the vector in bold, but when we are writing with hand, we always put an arrow on top of the name of the vector because we can, to make it easier, because it's not easy to make it bold every time we want to write the name of the vector. So we just write the name with an arrow on top of that. Or if you look at the next example, you will see that the initial point is P and the terminal point is O. So this vector is called PO, and the magnitude is called PO in that notation. Or we can call it with a different name, which is in this picture, the name of the vector is A. Two vectors are equal even only if they have the same direction and the same magnitude. If you look at this example, you will see that we have two vectors, they have the same length and they are in the same direction, which means they are equal. Or in this example, also the vectors are equal because the length or the magnitudes are the same and they are pointing to the same direction. But in this example, the last one, the length of the vectors are not the same. Also, the directions are not the same. They are pointing into two different directions. So they are not equal. For having two equal vectors, we have to have the same magnitude and same direction. If we have two vectors that they have the same magnitude, but pointing on the opposite direction, they are called opposite vectors. And you can see a picture of those two vectors here. They have the same length, same magnitude, but in opposite direction. And for showing the opposite vector, if the name of the vector is v, we call the opposite is negative v. If it's u, negative u. How we add two vectors? For adding two vectors, we have different methods. The sum of the two vectors is also a vector, and that vector is called resultant. But to find the resultant, to find the sum of the two vectors, we may show with different methods. One method is that if we want to add two vectors A and B, we can place the initial points of B on the terminal point of vector A. And if we place vector B, that the initial points of B is on the terminal points of A, then the vector that starts from the initial of A to the terminal of B, that is the resultant, that's A plus B. So you can see the vector A, that's the initial, that's a terminal. For vector B, the initial is on the terminal of A, and The terminal is on this part. So starting from the initial of A to the terminal of B, it gives us the result. Another method is just using a parallelogram rule. That means we use this rule when the two vectors are starting with the same initial. If the two vectors have the same initial, that's vector A, and this is vector B, they are starting at the same point, same initial point, then we can complete a parallelogram. That means having a vector parallel to vector B with the same direction of vector B, and then having a vector parallel to vector A with the same direction as vector A, then we can create a parallelogram, and the diagonal of this parallelogram is the resultant, or A plus B. These are the geometric methods to show this resultant. But what do we do for adding? We're just adding the values. And you will see in the next page that how we can add the two vectors when we have the vector component. And when we use parallelogram, we are showing that the vectors have a commutative property. That means A plus B is exactly the same as B plus A. It doesn't, so you have A plus B or B plus A. If you look at this direction, that's A plus B. If you look at this direction, you have B plus A. And the answer for both of them is the same. How do we subtract two vectors? For subtracting, we also use the method that we learned for adding, but this time we add the one vector with the opposite of the second vector. Instead of saying subtracting vector A and vector B, we say we are adding vector A with the opposite of vector B. So we have two vectors, A and B. So if you want to subtract, you have to find the opposite of vector B. Opposite means the same length with the opposite direction. And then use one of those methods, or using parallelogram rule, to find the sum of A and opposite of B. A scalar multiple of a vector. When we have a vector like vector u, if we multiply it by a number, numbers, when we talk about vectors, the numbers are called a scalar. When we multiply by a number with scalar, like 2, 3, 1/2, 3/2, we are actually changing the magnitude and the direction. If we just multiply by a positive number, that means we are changing only the magnitude. If we had vector u, 2u means just increase the length of the vector u twice more. If we multiply by 3/2, that means we are just changing the magnitude. But if we multiply by a negative number, negative 2u, these two is changing the magnitude, but this negative is also changing the direction. That means the vector must point in the opposite direction. And you can see vector u and negative 2u here. Negative 2u has a length twice of vector u, but in a negative direction, in the opposite direction. Now let's look at the algebraic interpretation of the vectors. So all we talked so far for adding, subtracting, or multiplying was the geometric form of those, but we mostly need the algebraic form, which means when we introduce the vectors by a vector component. A vector component, which we show with this notation, has two values like x and y, but instead of putting in parentheses, we put it in this notation. So we call it A and B. If the vector start, the initial point of the vector is on the origin, since the origin starts at 0 and 0, So A and B are the exact point of the terminal. So if the terminal point is A and B, the vector components are all A and B. And A, which means the x value of the terminal point, B is the y value of the terminal point. So that's why the A is called the horizontal component, because it's showing the x value, showing the value on the horizontal axis, and B is called the vertical component because it's on the y-axis and showing the vertical component of the vector. And if we have the vector component, if we have A and B, and they ask us to find the magnitude or finding the length of this vector, we are going to use a right triangle property to find the length of the vector. Since right now we have a right triangle, everything that we learn about the right properties of the right triangle works on this one as well. We know that the length of the vector or the magnitude of the vector is exactly the hypotenuse of this right triangle. And in every right triangle, we know that the hypotenuse, which is the magnitude of the vector, is hypotenuse squared is a squared plus b squared. And if you take the square root from the both sides, you see that the magnitude is the square root of a squared plus b squared. So to find the magnitude, we just need to square both of the horizontal and vertical components and then add them and then take the square root. We can also use other properties of the right triangle because we learned that in every right triangle, this angle that is created here between the vector and the x-axis, if I want to find the sine of that angle, the sine of angle theta, it's the opposite over hypotenuse. Hypotenuse is the magnitude of vector u. I also know that the cosine of that angle is the adjacent over hypotenuse. We also know the tangent of that angle is opposite over adjacent. And we can use this tangent formula every time we want to find the direction for any vector. And we can also use these two formula with just cross multiplying to find the horizontal component or vertical component. But we only use this formula if the magnitude and the angle and the direction of the vector is given to us. But if we have the vector component, A and B, that means we know the horizontal and vertical component. We don't need to use those formulas to find them. So we usually have two different cases when you are facing with the problems. Sometimes we have the vector components, A and B. Sometimes we have the direction and the length of the vector. But if the vector is not starting at the origin, everything that we talked so far was for the vectors that the initial point is on the origin. We only look at the terminal point, and that makes my vector component. But if the initial point is somewhere else, for example, is a point P, and the terminal point is a point Q, to find the vector component, we need to subtract x values and subtract y values. And when you are subtracting x and y, make sure that the terminal point must be first and then the initial point. We always start from the terminal. We say terminal minus initial. x2 minus x1 and y2 minus y1. And then after subtracting x values and y values, we have the vector component. We have a and b. So this is our a and this is our b. And then we can use other properties or other formulas that we learned so far. Unit vector. Unit vector is a vector that its length or its magnitude is 1. We have two important unit vectors, which is called I and j. I is a unit vector which its length is 1 and it's on the x-axis. It's along the x-axis. J is a unit vector, which means a vector with magnitude 1 on the y-axis. So I is always on the x-axis, J is always on the y-axis. I represent the numbers of the horizontal component, J means the numbers of the vertical component. That's why if you have the vector component, for example, you say, okay, vector U is 3 and 4, you have the vector components A and B. That means x values is 3. That means we have 3. 3 is the horizontal component. So the horizontal components can be also shown by 3i. And 4 is the y values, means 4j. So that's another form of representing the name of the vector. So instead of showing the name of a vector as a vector component, we can show it in terms of I and j. But make sure when you are writing 3i and 4j, you have to add them together. So this is another form of writing the vector, the name of the vector, in terms of I and j. Let's look at an example. It says find the magnitude and direction angle for this vector. So the vector components is given to us. That means A and B. Then we want to find the horizontal and vertical component. Okay. First, we want to find the magnitude. Magnitude of vector U is always coming by this formula. A squared plus B squared. A is 3, B is -2. We need to square them, then add them, then take the square root. So these are the steps that we follow. First, square them, then add them, then take the square root. 3 squared is 9, -2 squared is 4. Then we need to add them. Then, if it's a perfect square, we can take the square root. If it's not, like 13, we have to just stop here. And that is the magnitude of vector U. So the magnitude of vector U is square root of 13. To find the direction, we need to find the angle. Angle, that means we have to use the tangent formula, because tangent formula is the only formula that needs B and A. We can also use the sine and cosine formula, but since we only need B and A, not the magnitude, it's better to use tangent. So to find the tangent of that angle, we just need to divide B by A. B is -2 and A is 3. So the tangent of that angle is -2/3. But we want to find the angle. What is the angle? What's the angle that this vector is making with the x-axis? So we have to use the tangent inverse key and see what angle do we get. And if we type this one in calculator, -2/3, we will get -33.69. If I want to show you, -33.69 is this. That's -33.69. That means this is my vector. You can also find the vector, show the vector by the vector component, because you know that 3 and -2 is 1, 2, 3, 1, 2. It's over here, so that's your vector. And this is -33.69. But we always represent the direction angle in positive form, because we learn in geometry that the positive direction is a counterclockwise direction. So we need to find this angle. Okay. Different color. This is the angle we want to find. Or this is the angle I want to find as the direction angle. To find that, we just need to subtract 33.69 from 360 degree. And if we subtract this from 360, we get 326.31. And that, so this is the direction of the direction angle for this vector. Now it's asking us to find the horizontal and vertical components. The horizontal component is A and the vertical component is B. We don't need to find them because it's all is given to us. So the horizontal component for A is 3. The vertical component or B is -2. Okay. Now we want to find another unit vector, but when we talked about unit vector, we talked about the two famous unit vector, that one was along the x-axis and one was along the y-axis. But if we want to find a unit vector which is in the same direction as our vector, what do? We can just divide the magnitude, just divide the vector components by the magnitude of the vector. If we do that, we will have another vector component and which has the same direction as our vector. For example, I have a vector 4i minus 3j. 4i minus 3j means the horizontal component is 4 and the vertical component is -3. That means if you want to show in graph 1, 2, 3, 4, 1, 2, 3, so this is my vector, vector B. And you can see the direction of this vector. And I want to find a unit vector. That means I want to find a vector which the length or magnitude is 1, but has the same direction as this vector. So what do? We just need to find the magnitude of this vector first, and then divide the vector component by the magnitude. So let me just, that's the vector, divide by the magnitude. Okay. How do we find the magnitude? Just using the square root property, a squared plus b squared. So a squared, a is 4, b is -3. First we have to s square them, then we have to add them, then take the square root if it's a perfect square. Okay, so the magnitude is fine. Now what do? We divide the vector by its magnitude. So divide the vector, your vector is 4i minus 3j. That's right. You have to divide it by its magnitude. Divide it by 5. You can divide each separately. You can write it as a 4 over 5 I minus 3 over 5j. Or you can divide vector components. 4 and -3, you can divide each by 5. So now we have a vector component, which if you find the magnitude of this vector, you will get 1 because it's a unit vector. But if you graph it, you will see that it has the same direction as your vector V. Operation with vectors, how we can add them, how we can do the scalar multiple. In the previous pages, I showed you the geometric part. I show you how we can add vectors when we have the graph of the vectors, how we can do the scalar multiplication, but now we want to do it algebraic. If we have vector components, we have vector components of two vectors, how we can add them? Just add the horizontal components together and add the vertical components together. That's it. How we can subtract them? Subtract the horizontal components, subtract the vertical components. How we can do the scalar multiplication? How we can multiply a number by the vector? We have to multiply the number by both of the horizontal and the vertical components. It's easy. Let's look at this example. We have a vector u and vector v, and we want to find each of these parts. First, u plus v. So u plus v means adding two vectors. I want to add vector u by vector v. Just add the horizontal components and add the vertical components. X values together, y values together. And negative 2 plus 4 is 2. 1 plus 3 is 4. So, and that's the final answer. Negative 2u. That means we want to do a scalar multiplication. We want to multiply negative 2 by vector u. When you want to multiply a number by vector components, you have to multiply it by both of the horizontal and vertical components. Multiply negative 2 by negative 2, which is positive 4. Multiply negative 2 by 1, which is negative 2. That's it. Next one, we want to find 3u minus 2v. That means I have to find 3u, multiply vector u by 3. I have to find 2v or minus 2v. So it doesn't matter. You can just multiply positive 2 times v and then subtract, or you can multiply negative 2 by v and then add. So you can find 3u and negative 2v and then add them together, or you can find 3u and positive 2v and then subtract. So that's it. That works the same. So if I multiply vector v by 2, and then I want to subtract. So let's do the scalar multiplication first. 3 times u means 3 times negative 2, 3 times 1. 2 times v means 2 times 4, 2 times 3. Now I want to subtract these two, negative 6 and 3 minus 8 and 6. For subtraction, we need to subtract the horizontal components, negative 6 minus 8, and we need to subtract vertical components. Negative 6 minus 8 is negative 14, and 3 minus 6 is negative 3. And done. That is the final answer. So we can easily add or subtract the vectors. We can multiply a vector by a number. But if you want to multiply two vectors together, this is called the dot product. Dot product, which is called the inner product, it's when we want to multiply two vectors. We want to multiply vector u by vector v. And when we do a dot product, that means the final answer is just a scalar, it's just a number. Why? Because after multiplying the horizontal components and multiplying the vertical components, we need to add them together. So we will add up. When we add them, we just end up with the number. That's it. So the answer for the dot product is not a vector anymore. When we add or subtract, we always end up with the vector component, vector component, vector component. But for the dot product, we just end up to a number. For example, we want to find the dot product for these two vectors. So what do? We have to multiply the horizontal component, x values, 4 times 2. We have to multiply the vertical components, y values, and then add them together. And I know 4 times 2 is 8, negative 3 times 7 is negative 21, and 8 minus 21 is negative 13. And you can see that the final answer after the dot product is just a number, just a real number. It can be positive, it can be negative, or it can be 0. The properties of the dot product, for the dot product, we have a commutative property. That means when you want to multiply u by v, that's exactly the same as v times u. Doesn't matter because you just want to multiply the horizontal components and vertical components. And in multiplication, we always have a commutative property. We also have the distributive property. If you want to multiply a vector by the sum of the two other vectors, you can multiply, distribute, and then add them together. And if you have a scalar multiplication of a vector and you want to do the dot product with another vector, it's the same as if you do the dot product with the two vector first and then multiply by that scalar, or is exactly the same as if you do the scalar multiplication with the second vector and then do the dot product with the first vector. If we multiply 0 vector by any vector, we always end up to 0. And if we do the dot product for a vector by itself, it's exactly the same as the square of the magnitude. These are the properties of the dot product. But the geometric interpretation of the dot product, it also explains that if we want to multiply two vectors, which we know that we get a positive or negative or 0, this multiplication involves the angle which is between the two vectors as well. That means that we can use this formula. For the dot product, we have two formulas. So for dot product between u and v, we can say a1 times a2 plus b1 times b2. We use this formula when we have vector components, but we use this formula when we have the magnitude of each vector and the angle between the two vectors. And we can also use this formula to find the angle between the two vectors. And if we use this formula, find the cosine data, and then use the cosine inverse key, we will find the angle which is between the two vectors. For example, the question is asking me find the angle between these two vectors. Okay, and I know the only formula that to find the angle between the two vectors is this formula. That means I need to find the dot product. I need to find the magnitude of each of the u and v. Okay, let's find them first. How do we find the dot product between u and v? When we have vector components, multiply horizontal components, multiply vertical components, and then add them together using this formula. And then 4 times 2 is 8, negative 3 times 7 is negative 21, 8 minus 21 is negative 13. So we found the numerator, negative 13. We also need to find the magnitude of each vector. We need to find the magnitude of vector u and magnitude of vector v. For finding magnitude, we use the square root formula, which is a squared plus b squared. A squared means 16, b squared means 9, 16 plus 9 is 25, and the square root of 25 is just 5. Now we need to find the magnitude of vector v. S squared the horizontal component, S squared the vertical component, and then add them together, which is 53. Okay. Now, after finding this fraction, which you can see that there is nothing to simplify and there is nothing to multiply, and this is my final answer. Then we are going to use the cosine inverse key. That means we need to type this one in the calculator to see what do we get. Okay, let's type this one in calculator and see what is the cosine inverse of negative 13 over 5 root 53, and the answer is 110.92, and that's the angle between the two vectors. Next example, we have two vectors. We want to find the angle between the two vectors. Again, we're going to use the same formula. That means we need to find the dot product of u and v. We need to find the magnitude of u. We need to find the magnitude of v, and then divide by each other. So if I find the magnitude of u using the square root property, I square them first and then take the square root. Magnitude of vector v, okay. Find the dot product, multiply the horizontal components, multiply the vertical components, and then add them together. 6 times 3 is 18, 2 times negative 2 is negative 18, and 18 minus 18 is a 0. And then if I replace them here into the formula, we get 0 over square root of 40 times square root of 90. Do I need to multiply square root of 40 by square root of 90 or just simplify the radicals? We can do that, but we know that in fractions, if the numerator of a fraction is 0, no matter what is in the denominator, the whole fraction is 0. That's it. I don't care what's in the denominator, because since the numerator is 0, that means the whole is equal to 0. That means the cosine of the angle between the u and v is 0. Now, what's the angle? What is the angle that its cosine is 0? It's 90 degrees. Every time you see that the dot product is equal to 0, remember that the angle between the vectors is 90 degrees. Or you can say that the vectors are perpendicular to each other. Or sometimes you may see that they are asking you, are these vectors perpendicular? That means find the angle between the two vectors and see if it's 90 degrees. And to do that, you only need to find a dot product. If you find a dot product and you just get a 0 at the end, you say, yes, the vectors are perpendicular.